Hi everybody, this is Mr. Short. Today you can see what we're going to do is we're going to take a look at the 3.2 pre-post learning concept check. The key concept here, the foundational skill that we're going to learn about, is drawing Lewis structures related to covalent molecules. So what I'd like you guys to do is to start by reading each of the four statements, use the standard plus check minus rating system in the before column, and then when you're ready we're going to take some real brief notes concerning Objective 2, especially related to polyatomic ions. So before you get started with that, I want you to go through and use the plus check minus system in the before column. Okay, let's take some brief notes related to Objective 2, especially concerning polyatomic ions. The prefix poly means multiple or many. Think about Greek mythology. The ancient Greeks were a polytheistic society. They believed in multiple gods. Polyatomic ions are multiple atoms that combine together to form a single ion with a particular charge. So our definition of polyatomic ions is multiple atoms that combine to take a single charge. I also want you to note that if you take a look at the back of your periodic table, we've got a list of 9 common polyatomic ions on the back of our periodic table. Let me show you that real quick. Take a look back here. You'll find this list of 9 common polyatomic ions. If you take a look at the names of these, you'll notice quite a few names that you might be familiar with. For example, cyanide is a poison or a toxin. And what you'll notice about the formula for each one of these polyatomic ions is that they all have multiple atoms, like carbon and nitrogen, that combine to take a particular charge. -1 in the case of cyanide. In the case of phosphate, it's multiple atoms, phosphorus and 4 oxygens, that combine to take a particular charge, -3 in this case. So again, all of these 9 common polyatomic ions that are right here, they all have multiple atoms that combine to take a single charge. Note that by saying single charge, we don't mean a charge of +1 or -1. We just mean it takes a particular charge. Here's the last note related to this. When we draw Lewis structures, what we need to do is we need to space out the bonds, which are electrons, and we need to space out the non-bonding electrons as far away from one another as possible. So again, when drawing Lewis structures, space out bonds and non-bonding electrons as far as possible. Later on, what we're going to learn in this unit is that Vesper explains why we have to space out those bonds and non-bonding electrons as far as possible. The EPR stands for Electron Pair Repulsion Theory. Okay? This is a concept, this is a theory that explains that paired electrons will repel from other paired electrons. In just a couple minutes, probably what you're going to do is to take out the first example of drawing Lewis structures, and you're going to see that I try to space out bonding and non-bonding paired electrons as far from one another as possible. All right, thanks a lot, guys. Have a great day.